to imagine our universe so immense that it goes out in space in all directions forever and ever and ever with no end. Here we are somewhere on this tiny little planet we call Earth. It revolves around the sun at a speed of 18.6 miles per second, and we are fully dependent upon it for our very existence. For when our sun comes to an end, so does Earth. Think about it. How many of you watching this tape is aware of our universe? We will go back deep into space and look at our home planet from some distant galaxy. Due to the tremendous distances, we must measure it in light years. That means if we travel at the speed of light, 186,000 miles per second, we would go 5.88 trillion miles in one Earth year. We will look back from space 5 million light years away and observe our home galaxy called the Milky Way. That means in space we will be 5 million Earth years younger than we are today if we are to look back at Earth in its present time frame. That's the time it will take light to travel from Earth to where we will begin our observations. Shall we begin? Fasten your seatbelts. We're on our way to the outer fringes of space. We will head for this distant galaxy. And make our observations from this point. Now that we have arrived at our destination, we will look back at one corner of the universe and we will explore the local group of galaxies. On this local group of galaxies, there is one little spot there. We will look at that spot and project it to a larger scale so we can see what it looks like. So vast is space, so insignificant a tiny corner of it that we need a 4-stage view, 4 leaps of scale just to find the solar system. Even the smallest dots are not stars, but entire galaxies. Our solar system is still far too small to spot. To see it, we must imagine the biggest jump of all and zoom in on a shining spiral arm, the Orion arm. As we go closer, the swirl of light sharpens into thick clouds of bright points, stars like powder spilt on black velvet. We will explore this local group of stars. This cube represents 3 million light years across. Next, we will take a closer look at the Milky Way. In order to explore the Milky Way in detail and see where our planets and the sun exist in it, we must expand our view again. This is the Milky Way. It is 700,000 light years across. The arrow points to the Orion Arm. The Orion Arm is where our solar system is located. It's a very small corner of the Milky Way. Still closer, the stars seem to separate, parted by the light years of emptiness between them, until one bright spark lies along in the darkness, the sun. But we must come even nearer before the planets finally fully appear. We will expand this view and we will take a look at the solar system. Closer look at the solar system. It is only 1/800th of a light year across. We'll now take a close look at the sun. As you can see, all our planets revolve around the sun. This is a view of our solar system. It compares distances. If Pluto's path were about the size of a bicycle tire, the orbits of the 4 inner planets would fit on the face of a quarter. Now this is Pluto, the furthest one out, and this has this orbit. The next one is Neptune. It has this orbit. The next one is Uranus, which has this orbit. The next one is Saturn, which has this orbit. The next one is Jupiter, that has this orbit. And in between our planets is the asteroid belt. When we explore the planets around the sun within the asteroid belt, the furthest one out is Mars with this orbit here. The next one is where we live, the planet Earth, in this orbit. The next one out is Venus, which has this orbit here. And the closest to the sun is Mercury, which has this orbit here. And last but not least is our sun. The birth of our solar system remains a puzzle. Some 4.6 billion years ago, scientists think a vast cloud of gas and dust, perhaps shaken by a nearby exploding star, collapsed into a spinning disk. "10 million years later, gravitation pulled so much material to the center that pressure and heat there lit a nuclear fire. The sun began to shine. Other material slowly collected into lumps of hot solids and gases. "20 million years later, the gases cooled into planets. Later and up to today, the planets look like this. All are built like Earth and everything on it. If chemical elements evolved from that original cloud amid the stars, even the oxygen in our lungs, the iron in our blood, the calcium in our bones, and so on. In a way, we are all made of stardust.